And my name is Aaron, and I am the faculty liaison for Cell Collective. It's my job to support faculty in their use of our technology, and I'm thrilled that you've taken the time to learn more about how to integrate computational modeling and simulation in your course. While I'm introducing some material, you can visit cellcollective.org and register for an account. I put that link in the chat. You can visit that. Click sign up in the upper right hand corner and register for an account. That will enable you to save your work, which is helpful, will be helpful later. We'll get into the technology in just a minute. A quick background, Cell Collective is a research grade platform for modeling and simulation of systems ranging from simple to complex. Researchers around the world use this technology on a daily basis. Here at the University of Nebraska-Lincoln, the Helicar Lab is working to build a multi-scale virtual immune system. By working to better understand the dynamics of the immune system responses under varied conditions and across multiple scales, we can predict novel uses for existing drugs to address a range of immune system problems. We are now working to experimentally validate some of the most promising predictions we've made so far. The basic science is interesting, but you are here today to learn about the educational application of this technology. From the beginning, Cell Collective developers knew that even life science researchers are not all experts in computational modeling. As a result, the technology was designed to be both intuitive and dynamical. The intuitive nature is significant because it means that students don't have to know how to code or use command lines or even understand mathematical ideas like Boolean logic to get started modeling. They can come as they are. Dynamical means instructors and students have control over nearly every parameter of their models and the resulting simulations. In addition, the simulation output, while predictable, is not predetermined. Together, this intuitive and dynamical system enables students to build models, simulate behaviors, and interpret and analyze the results, mirroring the work done by scientists around the globe. It really is a research grade platform. So I want to take you now through the technology itself. I'm going to show you how it works in a simple and decontextualized example, which will hopefully give you the confidence to try lessons you may be interested in using with your students. Now, hopefully you've had time to register for an account. We're going to go to Get Started. Oh, I should have said that first. Get Started, and then up here on this little person, you can click either Sign Up, Sign In, or Language. If you click Sign Up, it brings up this bar, first name, last name, email. You create your own password and where you're from. All this does is help us establish a profile for you so that where you can save your work on our system. We don't use it for anything other than that. So I'm going to sign in. Like this. For now, we are going to navigate to this tile called Cell Collective Training Module, Factors Influencing Exam Scores. When you're here, we're going to click this big red button that says Start Lesson. When you do that, it creates a copy that is just yours so that you can save your progress. After clicking, it says Restart Lesson, and then there's a tab up here that says Start Here. In many of our lessons, there is an overview of the topic for each lesson on this landing page. This one does not have objectives right now, but the lessons that have objectives tied to either NGSS or Vision and Change or both, those will show up right here. But what you want for your students and what we'll go through today is the content. So we're going to click this tab that says Start Here and build a computational model. So To start, models have really three parts. There are components, there are connections, and there are conditions. And so these first few pages show us how to work this. So the very first thing we do in Cell Collective is start adding components to our model. I am going to go down here and just double click, and that brings up a component called A, and we're going to label that exam score. The reason is this activity is made to show the relationship between studying, stress, and the impact of those on exam scores. So down here we created a component called exam score. We're going to add two more components. So I'm going to double click again up here and add another one called studying, and a third called stress. Double click and name your components. This part is fairly straightforward. Where you need a little background is these components can be either internal components or external components. We're going to make studying and stress external components by pushing Shift and click, and that should turn orange. We can push Shift and click, and that will also turn orange. These are external because they are not controlled by anything else in the model. But we will leave exam score an internal component because it will eventually be regulated by both studying and stress. So shift clicking a component will turn it either external or internal, like this. Okay. Adding components, we can go to page 2, and now we're going to add connections. So studying increases exam score. So to create a connection between studying and exam score, I'm going to click on this external component, and I'm going to drag down until it attaches to exam score, our internal component. And you can see this arrow is green. That means it is a positive regulator. Stress is likely a negative regulator of exam scores. So we're going to do the same thing here. Click on stress, drag down to exam score, and you see that we have this connection made. But we want this one to be negative. So to create a negative regulator, we're going to hold down shift, and then click that arrow. Just like with our components, shift clicking toggles between internal and external components. Shift clicking a connection toggles between positive and negative regulators. We now have built a computational model. You can delete a component if you select that component and push delete. It should go away. If it won't, back here on page 1, we have some instructions. Can't delete a node, components, nodes. Ensure you are in edit mode. If so, you can select the node and click the negative sign next to the pencil icon. So say we add one up here and we want to delete it. You can select that and just push this negative button up here, and it will remove it from your graph, from your model. Okay. So now we have a model. The reason that computational modeling is valuable is because it is more than just a model on a page in a textbook. This model you can use to look at the behavior of the system given the components and the connections that you have built between them. So we call exam score an internal component because its activity is determined by these external components. So what I'm going to do is click this box to the left of exam score, and you'll notice that down here exam score turns dual colored, kind of gray and blue. You can also achieve that by just clicking exam score in the middle, and you'll notice that this arrow appears and disappears. Selecting that makes it show up on our simulation graph down below. We're going to set the simulation speed to 1 and the sliding window to 50. If yours is not already at 50, you can click that number and just type 50, or you can slide this slider back and forth until you get to 50, however you want. And now we are going to push the play button right here, and we're going to watch the simulation graph down at the bottom. So we push play and pause. Notice what's happening with our exam score. We see that the exam score is 0. The activity level of the exam score is 0. Why would exams be 0? Well, exams are an internal component and there is nothing telling it to go up. There's no positive regulator because our external components are set at 0% activity. So to see the effect of external components on internal components, we need to manipulate their activity. So advancing to page 4, we can see that changing this studying to 100, we're going to take studying activity level to 100%, and we're going to push play. And what happens is exam score goes up. When students study, they do better on exams. This is intuitive, right? If we increase stress, what do we predict to happen to exam scores? Well, they should decline. And that is what we see in our graph. There are lots of ways you can play with the various levels of studying and stress and save your work. This is showing the interplay between these two external components and the influence on the internal component exam score. In reality, we know that there are lots of other factors besides studying and stress that impact exam scores. So we are going to add another component here. We're going to increase the complexity of the model. So I'm going to double click and add note quality to our panel. I will show you quickly, this pencil up here should be blue on the screen in the middle. This toggles between editing mode and viewing mode. So when you click that, it becomes an eye and you can move these things around. So I'm going to stretch that out a little bit so that we can see note quality. And then I'm going to go back to edit mode so we can make our connection. So we have note quality. We want this to be an external component, and we're going to connect that down here to exam score. Now our model is becoming more complex. We'll advance to page 6. It turns out that it's more complex even than just these 3 independent components influencing exam score. How a student studies depends on the quality of their notes. So we're going to make this a little more complex. If we click on exam score, now we can see how exam score is being regulated by all of these components. Right now, these hold equal weight, but what we want to do is set a condition that studying is only effective when note quality is good, or studying is impacted by the quality of notes. So underneath studying, I clicked this plus by conditions, and what I'm going to do is hover over note quality, click and drag down to where it says drop components here. And what you'll notice is it says studying is a positive regulator if or when note quality is active. Now, because we've set this as a condition under studying, we can get rid of note quality up here. So I'm going to move to the edge of this box and click X. And now we have set a condition that studying is effective when studying depends upon note quality. Those instructions are spelled out in this panel right here. So now we can run another simulation and see the effect of note quality and studying on exam score. So just like our first one, I'm going to click exam score. This is what we want to view. I'm also going to click studying, select studying here, so that they both show up on the graph. All right. I set studying to 100%. Both of these are at 0. And now I push play. What do we expect to happen? Students study. Note, students are studying 100% of the time, but their exam scores are still low. Why is it different now than it was in our first simulation? It's because note quality is a condition of studying. If note quality is not active, then studying doesn't really matter. So if we increase the quality of notes and then we push play again, then we expect exam scores to climb. After building this model, you can imagine that there are lots of ways to set these parameters, many questions that we could ask, and different versions of this experiment that we could simulate. In fact, if you go to page 8, there's a little cheat sheet or a how-to on setting all of the components. You can see the regulatory mechanisms, the internal and external components, everything you need to run any experiment that you want. You can feel free to play with that for a while if you want. I will tell you quickly that the training module is simple and decontextualized, but it demonstrates the mechanisms of adding components, creating positive and negative connections, and setting conditions. Using these tools, students and researchers can build models that are quite complex. If we go back to the dashboard, and you do that by clicking this Cell Collective logo in the upper left-hand corner of the page. If we click that, that navigates back to the dashboard and you can see all the lessons that we have developed so far. Our lessons are designed, we don't have time to walk through each one of those right now, but I would encourage you to browse our selection and find lessons that could be useful in your course. Our lessons are designed to engage students in both model building and simulation of model behaviors. As a result, some of our lessons are broken into 2 or more pieces. Cellular respiration, for example, has a lesson titled Exploring the 5 Processes of Cellular Respiration, and another one called Simulating the Behavior of Cellular Respiration. Here is Exploring the 5 Processes. And here is simulating the behavior down on this corner. Ideally, students will complete both lessons as it's difficult to understand the simulations without first making sense of the model. Here at UNL, our lessons are used in a variety of courses in a variety of ways. Some courses use them in lecture, others in lab, others in recitation, others as homework or extra credit assignments. They're used in introductory as well as upper level courses. Cell Collective is really flexible enough to fit wherever you want to put it. And it's my job to help you figure out the details. This is the end of my formal comments, but I will spend a few minutes answering your questions if you have them. Please know that if you dig into some of these lessons over the coming days and weeks and you have questions, I am here to help. Send me an email. We can set up a phone call or a Zoom conference and get you started using Cell Collective.